Good day, everyone. I'm Nancy Molenda, Communications Manager for the Aluminum Extruders Council. I'd like to welcome you to our webinar, Aluminum Extrusion, Designing to the Limits of Your Imagination, presented by David Asher and Todd Boyer. All computer, audio, and telephone lines are muted, so if you have a question during the webinar, please select Q&A or chat from the toolbar. Type your question in the dialog box and our presenters will address your question at the end of the presentation. Following our presentation, an email will be sent to you. We ask that you take a moment to answer the brief survey about today's presentation. Now it brings me pleasure to introduce our speakers for today's webinar. David Asher is passionate about educating students on the benefits, applications, technology, and design of aluminum extrusions. He is Process Optimization Manager for Bonnell Aluminum, headquartered in Noonan, Georgia, and has been working in the aluminum extrusion industry for nearly 40 years. He has been actively involved in the Council's academic outreach program for nearly 10 years by providing educational presentations to schools near his home in Indiana and participating as a judge for the ET Foundation's International Aluminum Extrusion Design Competition. For more than 10 years, David was actively involved with the AEC Die Committee, serving as chair for several of those years. He continues to participate on the ET Seminar Committee, a guiding body for the aluminum extrusion industry's premier technical conference, the International Aluminum Extrusion Technology Seminar, also known as the ET Seminar, which is produced by AEC and the ET Foundation once every 4 years. Todd Boyer is Director of Business Development for Mid-States Aluminum Corporation in Fond du Lac, Wisconsin. He participates regularly as a judge in the ET Foundation's International Aluminum Extrusion Design Competition and is actively involved in the AEC academic outreach team. Todd loves talking with students and instructors on the aluminum extrusion process and often hosts plant tours to provide real-world learning opportunities. Now, I'll turn the webinar over to David Asher.
I would also like to extend my welcome to everybody who is on the call. Appreciate you all taking the time to be with us today. This is, as Nancy said, I'm David Asher with Bonnell Aluminum, and I'm here today with Todd Boyer from Mid-States Aluminum. And we're representing the aluminum extrusion industry in North America through the Aluminum Extruders Council. Over the past 5 years, our industry has been increasing our involvement with various universities, colleges, and other educational institutions, teaching students in a variety of disciplines about aluminum extrusions, the extrusion process, our product attributes, and design considerations. Our goal today is to provide you with an overview of the types of information we can cover in a session with your students, our teaching tools and techniques, and the benefits of collaborating with our industry and the support that our industry can provide you. The slides that you're going to see are simply representative of the topics we're prepared to present. So with that, we'll move on to what a typical presentation might look like. We'll be discussing the advantages of aluminum, the advantages of using the aluminum extrusion process, some key design and processing concepts, some illustrative case examples. We'll be talking about how schools can engage with us and we can engage with the school and the support that we as an industry can provide you. And we'll also be talking about our industry scholarship that comes about through the annual extrusion design competition. So what does one of our presentations look like? Well, we work hard to keep it interactive when as best we can. We want to send in one of our representatives as best as possible to do a kind of a hands-on presentation with examples of extrusions, with examples of tools and dies and other components of the process that we can bring in and allow the students to touch and have hands-on. Certainly there will be a PowerPoint part of the presentation, and again, the slides you'll be seeing today are simply representative of the types of material we can be covering off. We can structure the presentation to the class, whatever the type of class is, whether it be engineering, design, or some other discipline. We do have hundreds of facilities around the U.S., so chances are there is an extruder reasonably close to most of the schools in the U.S. Where we can find representatives who will come in and speak to you. For those of you who are international, we can structure a PowerPoint presentation to do this remotely, although obviously we lose a bit of the hands-on effect. So what are we going to start out with? We will be starting with kind of some of the highlights of both aluminum and aluminum extrusions. We'll cover the benefits of aluminum and also the advantages of aluminum extrusion. Again, the actual topics that will be covered will be dependent on the class and the structure of the class and what you as an instructor would like to see us cover off. For instance, in the case of some of the advantages of aluminum, we could be discussing some of the lightweight and strength applications of aluminum that go into areas such as automotive applications, as well as for instance, snowmobiles and the high strength and weight characteristics of aluminum in both of those applications. So, again, what exactly is the extrusion process is another topic that we can and will cover off. The extrusion process is really nothing more than a Play-Doh fun factory, although on a very large scale. The presses that we have and use are up to 3,000 tons hydraulic presses, in some cases even more than that. But the Play-Doh fun factory is one of the great examples of how the process works. And in some cases, we're able to actually bring in something such as that and or other miniature presses. We also talk about the recyclability of aluminum. Again, one of the key topics that students are most interested in. Aluminum is the ultimate recyclable material. And highly recyclable cost effectively, and universally recycled. Now, if we are going to be working with a design class as opposed to an engineering class, we can cover off several of the characteristics of extrusions that allow them to be incorporated and joined together in a variety of different methods, including dovetails, slide fits, and others. And I want to back up for just a minute. All right, I apologize for that, skipping that last slide. Anyway, we'll cover off the design topics of how extrusions can be joined together easily. Additionally, we'll be talking about some of the advantages of the process itself. In terms of tooling, and the cost of tooling and cost of getting products into production. The extrusion tooling is typically some of the least expensive tooling of most major manufacturing processes. As you can see on this particular slide, the tooling costs are typically under $5,000, and the time to get the product into service is typically quite short, which is one of the key advantages of designing products with extrusions. Now, there are limitations to the process, and we will go through some of the limitations that are associated with the use of extrusions. This involves things such as the size of the profiles that can be produced, the weight of profiles that typically can be produced, and other shape constraints, including how a profile can actually be structured best for extrudability. We also will review issues in and around alloys and alloy selections. And there are many alloys that are commercially available for extrusion, some of which are typically going only into decorative operations and do not have the great high strength to weight ratios as some of the others, and others that go into automotive applications. And we'll certainly review what each of these alloys is good for and how it fits into the product and into the extrusion process. And now I would like to turn the presentation over to Todd, who is going to go through a lot more information on what we can present on design and on finishing and on various examples of how extrusions are actually used.
Thank you very much, David. Thank you guys for being, guys and gals, for being part of this event. Our intent, as stated earlier, I think, and my intent and my passion is really to see extrusions be able to be utilized in an educational environment. One of the things that we run into on a regular basis is new design engineers, new application people who we're charged with developing extrusions or working in an extrusion environment, but they've had no representative experience from an educational standpoint, maybe a half hour or something in their classes. So I think the intent here is, again, is to provide education material to your students to help them be well prepared when they get into the workplace, both from working potentially with aluminum, but also designing and utilizing aluminum in their job functions. So some of the things that we talk about specifically, as David alluded to, are the design variables. Specifically in the extrusion area, it would be regarding shapes. And we speak specifically about good design practice. And this slide really shows a little bit of don't do this, do this. And so we will cover off that not only with a slide, but a lot of touch and feel parts that allow your students to engage in what they're learning in that session that we would provide. And this, again, extrusion design hints. So think about this. The world we're living in is all about optimization and cost reduction and time to market. And in this case, we show an example of how you can prevent the need to maybe drill and tap or just tap, and that's the not this, and how you can use self-tapping screws. Again, an example that's really tangible, and then you bring examples of actual products that are in the marketplace that they can relate to. It might be food service, or it might be something, but products they can touch and feel and say, oh, I get that concept. And that's alluded to in this slide here. The next opportunity that is there is the extrusions in maybe a 12-foot length or a 3 or 4 meter length may be valuable, but what we are seeing as an industry is a huge utilization of aluminum extrusions and following all of the secondary processes. So stretch forming, press forming, robotic cells, welding, stir friction welding, etc. But in this specific area, we want to talk about what they can do with aluminum extrusions from a fabrication and assembly perspective. That is where people are utilizing and applying them in new market applications. An example of the bending is the bending application that is done for maybe a common one that your students or maybe you on the weekend can attest to. This is a LED light bar. The extrusion itself is fairly difficult. It's a high aspect ratio extruded profile, and then it's formed and anodized. And so we talk about the stretch bending, the CNC machining and the anodize, and we talk about it in real life applications so that your students can connect with something that's tangible, not just a theory, if you may. As we move forward, the fabrication that we see also in the market space is heavy duty, focused on joining techniques. As you know, there's an immense amount of adhesive bonding that's going into applications, i.e. the Corvette that was shown earlier. So yes, there's welding, but then there's a lot of bonding that's going on with adhesives. And I think you guys from an academic standpoint understand that, but then we're able to speak to that, and we also have materials available for you and your classes, and also people who are already in the industry of how to be able to join products together. Stir friction welding, etc. So those are some examples of what we would cover. Another area is the opportunity to talk to your students about finishing. And finishing is, you always think about finishing, is it paint or is it chrome plated or what have you, but the aluminum extrusion is very receptive to a number of different finishing processes. And so we will walk through a number of those, again, with touch and feel examples, and connect it back to actual products that they can relate to. Cell phones, car paint, automotive paint related stuff, motorcycle applications where there's, the sexy, sizzly, cool looking anodizing that's multicolored. So those are some examples of the things that we would talk to them specifically about and answer questions that they might have. The next slide actually shows a little bit of what I call the sizzle of the color, and that is talks about anodizing and it not being a coating. And so we dig into the anodizing because anodize is really great for the end-of-life sustainability that you and your students are going to run into in the market space. Customers are talking about what happens at the end of the life, and a painted part has a value of the aluminum, but a less value than an anodized, which is literally an aluminum oxide, and its scrap value is effectively $1 for $1. So we'll talk about those things from an environmental standpoint and from an eco-friendly standpoint, end-of-life sustainability on new products. The next few slides that we're going to show you, and I want to speak to specifically, are just some of the things that we're going to talk to your students about. They're case examples. They're going to talk about weight reduction or packaging or servicing. And in this case, we'll talk to them specifically about the different material options that are out there in the market and in industry. And we're going to speak specifically about the use of aluminum and the values that it brings from a density and from a weight reduction. That is the biggest thing that we see in our market space today. It's all about making things smaller and lighter. And that's not limited just to the automotive sector, I might add. As we look at the next opportunity, this is a building and construction application where we are using aluminum extrusions extensively, both in a painted and an anodized finish way, and you get a lot of contemporary look. You also are working with some of the solar panels up in the roof section there, as you see. So it's structurally sound, but it also is aesthetically pleasing, and that's the opportunity that we want to share with your students about what are the applications and how they might be able to leverage those in a work world when they leave university. One of the areas that's been a growing market segment for the use of aluminum extrusions is in the solar energy industry. And this next slide is an example of what's really going on out there in the solar world. It is a significant impact on the sustainability and environmental green application of aluminum extrusions, but one that is not going away anytime soon from our view. We'll also be speaking about the transportation industry. There's a number of commercials. You see them on the TV when you're watching the playoff games or the soccer games or what have you, and you're going to see aluminum being used in pickup trucks, and you're going to see the competing arguments on the commercials relative to the value of the aluminum and the lightweightness and the value that it brings with regards to miles per gallon. As you're seeing there on the left-hand side, we're going to speak to them about stuff that kind of rocks their world as well, space frame applications, but automotive body applications, and the like. We'll also talk to them about what I would call specific engineered components in the next application. This is a really good connect of both plastic and steel and assembly and adhesives and Tox locking and magna locking all into one assembly that I think your students can really connect with, specific to what we would be doing. And so we literally will have touch and feel samples and showing them end use applications much similar to this, and talking about the advantages of how they can utilize extrusions in their work world. The next one, I love the medical industry, but I hope I don't have to ride in one of these too often. But these are, again, applications where there are extrusions, and when you go into one of these tomotherapy or MRI units, you're literally riding on aluminum extrusions. And so we speak to the fact that many times you don't understand the use of aluminum in our market space today, but many of your students may end up in a medical equipment related application, and we'll speak specifically to that as an example. Another area that's a growing area is the LED lighting market, and we'll speak exclusively on that. We have a lot of really good information on LED lighting and the applications thereof as that takes over the incandescent and fluorescent lighting applications in the industry. So, hey, this is all good stuff. So what the heck does it do for you as a professor, as an instructor, who are thinking about class materials for your students in the months and years ahead? And what we want to do is bring a value, not just a canned presentation to you and your students. We want to bring touch and feel samples, real life examples in an informal yet focused setting. And so I think we can help connect your students, because many of them are going to use aluminum extrusions in the market space when they leave your colleges and universities. On the other hand, there may be opportunities, very, very knowingly opportunities. How do we collaborate together relative to internships? I know that our industry is very engaged in internships. We here at Mid-States, I know Benell as well, others, are working directly with internship programs, 2- and 3-year programs, and many of these people are coming out of the university and colleges, graduating right into a full-time position with effectively their running shoes on. The support from the industry that we can provide are some of the things like this. Interactive classroom sessions, such as we are talking about, highlighting a little bit of what might it be encompassed in that view. But we also want to do physical samples, touch and feel. We want to provide plant tours. I will have the Illinois Institute of Technology in our facility, a whole applied science group will be here next month. And it's kind of the next phase of getting in front of them and sharing a presentation. Those are the exciting things, and the students are really looking forward to it. This happens to be a club, one of their technical clubs, not even a class. And it's self-generated, and that's a good example of what might work. So that is the intent. We want to help support what you guys are doing to educate and prepare your students for the workaday world in 2017, 2020, and 2030 that's out there for them as they come out of school. I just want to really thank you so much for the opportunity today, and I'm going to turn it back over to David, and he'll wrap up the next steps here.
All right. Thank you, Todd. In addition to the actual presentation that we will do about the industry, we also would like to be able to take a few moments in our presentations to talk about our annual design competition. Again, this is done every year and is open to students around the world. As you can see, for this year, the deadline is March 27th of 2017. Todd and I have both been very fortunate to be judges of the design competition for the last several years, and it's interesting to see the designs that come in from really creative and innovative extrusions to creative uses of standard extrusions. In fact, for the last couple of years, our winning entries have been senior design projects that incorporate standard extrusions that can be purchased anywhere. We're looking not just for, again, new applications of the standard extrusions, but innovative and creative designs of extrusions that typically come out of design classes. Again, the design competition is, deadline is March 27th, but I would like to just take a few moments and review what it looks like financially for some of the students if they do choose to participate. We have about $8,500 that's available for awards to students, and again, this year, as last year, the competition is sponsored by my company, Bonnell Aluminum, but we have $3,000 going to the first prize winner. And we also have, as Todd alluded to earlier, a very specific design challenge, which is to design a creative use of extrusions for LED lighting applications. So again, there are significant financial rewards available for students who choose to participate. Again, it may or may not be something that fits in with the classes that you would be teaching, but we certainly want to have the opportunity to give students the chance to participate. In addition to the financial benefits, I would like to just point out how you can find out more information about the design competition other than having one of us come and present about it. And that's by going to the website that's on the screen, which is ETF, or Extrusion Technology Foundation design.org, and that will take you to a link with a lot of additional information on the design competition, some of the restrictions that we have put on it to try to come up with more practical extrusion designs. And it's just a great source of information as you're looking to design and make a submission to the design competition. In addition to the design competition website, the Aluminum Extruders Council also has a website with links to lots of different information about our industry, unique products that are used, the benefits of extrusions, again, practical applications, creative applications, design considerations, and so on. So with that, again, we'll point out that if you are interested in additional information, again, we have the website, and we also will have contact information for Nancy and Duncan, who, if you reach out to them, they will link you to others who could potentially come in and share with your classroom. So with that, I will open it up to back to Nancy for any questions.
Okay, thank you, Todd and David, for a great presentation. Does anyone have any questions? I don't see anything in the chat boxes, but please feel free, as I'm talking, to jot down any questions that you might have. One of the things that David did touch on is that if you are, not in the North American area, we can certainly work with you to create a presentation for your class. And I think David or Todd, you can talk about how many members we have out there and how far-flung our members are, and we just have people everywhere. So we have about 100 extruder members. So, and they have sometimes hundreds of employees dotted all over North America. So if you're interested in having an AEC member come to your class, definitely contact us. Okay.
Yeah, I think maybe if I speak to that, there might be some universities or colleges that feel they're out of the mainstream in terms of where geographically. And I think a really good note there, Nancy, is the fact that we do have extruders literally all over the United States, and they are able and willing and well qualified to come and support and provide presentation to students, many of them driving 3, 4, 5 hours or half an hour. Depends on location to do that, and that's a commitment on our end to each of you as professors, instructors, etc., that we'll do whatever we can to support what you're trying to do with your class and provide a great education for your students.
Okay, thanks, Todd. And we do have a couple of questions coming in. One of the questions is there any way we can learn about the management side of extrusion manufacturing, the operational and management side? Do either Todd or David want to take that?
This is David. I'll take that. Again, whatever the class is, we will find someone, some way, somehow to structure the presentation to the requirements of the instructor and the students. Again, if you want to talk about the management of a facility, I mean, certainly each plant and each company manages things a bit differently, but we can certainly talk about, what kind of degrees lead to management positions within the extrusion business, and how at least the plants that we are familiar with are operating.
Okay, thanks, David. And we have another question from Dave Cotterman. He says, thank you for your presentation. Would you please let us know about the hiring prospects for industrial engineers in the aluminum industry for the next 5 years? Wow.
Hey, maybe would you let me take a crack at that one? This is Todd. It's a really good question, and I would tell you that our industry is growing on a fairly rapid pace due to the increased use of aluminum extrusions. So if you're dealing with an industry that's stagnant, well, there's going to be attrition as people come out of jobs, etc. But I think the aluminum extrusion industry is a very growing and vibrant industry, and I can speak for numbers of extruder members who are actively engaged in hiring engineering, industrial, as well as manufacturing related students, and aggressively pursuing internships to leverage the experience level and for both the student as well as the extruder member company. So clearly opportunities, and there is no shortage of, you said 5 years. We're seeing in our business plan about 3 to 4 years out, and we're seeing growth opportunity for the next 3 to 4 years minimum.
Hey, David, this is Duncan Crowdis. I'm a retired president of Bonnell Aluminum, and I feel so passionate about what we're doing with academic outreach that I've continued my work with the AEC as coordinator. And just to add to what Todd has just said, and as Todd indicated, we're increasingly getting into more and more downstream fabrication and assembly in almost all the extrusion operations across North America. And that really, plays very well into the hands of someone that's involved in focused process and industrial engineering. So I would suggest that, as we look forward over the next 5 years, the need for someone that the kind of skills that comes out of industrial engineering is going to accelerate. We had two panelists on this call, David and Todd, and I don't know about you, Todd, but I know David happens to be an industrial engineer.
Yeah.
Okay, thank you, gentlemen. We have one last question, but I'm not sure that it's quite relevant to what we're doing here. The question is, what is the best alloy to replace steel? I think that's probably getting into, the weeds at this point, but if either one of you want to take that question, you can.
I suspect that actually Duncan is one of the better ones to address that one. But normally when you're dealing with truly replacing steel, you're getting into some of the higher strength alloys, and one of them that is frequently now used in the auto industry where they are replacing steel is 6082.
This is Duncan. I can add to that. There's a tremendous amount of work that's being done looking at alloys and combining that with design considerations to get I would call it the most dilute alloy possible to provide the kind of characteristics that steel would in a specific application. We've actually done some modeling with a research agency looking at some of these things, and you'd be surprised at what can be done combining design and a more dilute alloy in getting those kind of strength characteristics. But again, as Nancy indicated, you have to look at every application, and the folks that we could put in touch with you know a lot about that. One of the things I'd like to add before we go is the next step could well be this was designed to kind of pique your curiosity. The next step could well be just a call saying, I'd like to learn more. And I think that would be a great segue into perhaps doing something more significant. So I encourage you, if this sounds like it may work for you or it has some interest that you'd like to pursue further, take a next step and contact either myself or Nancy at the Aluminum Extruders Council, and we can set you up with a call with an extruder in the area to talk about where you might go following this.
Great. Okay, thank you, Duncan and Todd and David. This was a great presentation. Just to wrap things up, today's presentation will be available online soon on the AEC website, and we'll send you a link once it's uploaded. The evaluation survey for this webinar will be sent to you shortly. Please share your comments with us. Your input is very valuable and helpful in developing future webinars. And as Duncan said, if you are interested in having an AEC member come to your class to talk about aluminum extrusion, please contact me at nmelenda@tso.net or mail@aec.org. Either one will work. This concludes our webinar for today, and thank you again for being with us.